Good morning once again. I want to welcome you to this seminar. Thank you so much for joining in. I'm going to mute everyone such that we don't have any bad noise coming from the different people. And in case you have anything, you want to tell us, there is something you want to communicate, or else we shall be raising up our hands such that we keep the discipline. So we shall be raising up our hands such that we maintain that discipline. So I want to request that when you enter the room, kindly have your microphone. Off such that we don't get any bad feedback. May I ask a volunteer to raise up the hand and you lead us in an opening prayer? Any volunteer who wants to lead us in a word of prayer? You can raise up your hand and then you take us through the word of prayer as we start our seminar. Okay. Yes, Nakazima. I've seen Nakazima. Unmute. Sharon.
Okay, have yourselves a prayer. Precious and loving God, we thank you for this day. Thank you for this moment as we're going to have this seminar. Guide us, protect us, and enable us so that we get what we are going to learn. In Jesus' name, I've prayed and believed. Amen.
Amen. Thank you so much, Nakazva, for the word of prayer. I want to welcome all those that are joining in. Thank you so much for joining us. Let me first display the questions that we are going to be discussing in this session. So when you look at my screen, you will be able to see the seminar questions. These are the seminar questions that we shared on your WhatsApp group. I think it was on Sunday. And by now, we expect that everyone has been able to go through them. These are the questions that we shall be discussing. We divided the questions into what we call the paper one questions. And all these were mock papers that were done by different schools. And we want us also to try out. So you can see which numbers are common in this paper, which numbers are common here that I need to know. So these are the questions that we shall be discussing in our seminar. We shall push our seminar up to 1, and then we shall cross from there. So those who have tried out the questions, I'm sure in the seminar, you'll just be ticking off those questions that you have done. And those who have not yet tried out some, I'm very sure that you'll be able to understand and pick something during the discussion. I want to ask you that have your pen, have a piece of paper, or have your math book with you, such that we try out the numbers. In the seminar, we need to do. So I want everyone to have a pen, have your calculator with you, have a book, such that you keep on trying. When our friend is discussing, then also you can try to look at the question, try to answer the question and see whether you come up with the same answer. And in case there is any error in the working, maybe when someone has made an error, then we can be able to collect it together. Let me ask those who have prepared to present, raise up their hands. In case you have a question that you want to present, there is a question you prepared for, kindly raise up your hand such that I can give you the co-host rights. In case there is any question that you prepared for to discuss in the seminar, kindly raise up your hand and then I'll be able to give you the co-host rights. I know some people, yesterday I got some people who wanted to present. Okay, I've seen Arthur is here. Okay, people who have questions who are going to be presenting, kindly have your hand raised such that we can give you the co-host rights. Otherwise, thank you so much for joining in. Allow me now to start off with the seminar. Allow me to invite Emilia Joy to be our first presenter. in this seminar. Emilia Joy, you are most welcome.
Thank you, Mr. Kaziba. Okay, good morning, everyone. My name is Emilia Joy, and I'll be doing number 13 of paper 2, which is under the topic of topic 6. So number 13 said, in a survey carried out by the Ministry of Health at Entebbe International Airport, on 150 travelers, it was discovered that 40 had visited Dubai, 35 had visited Wuhan, and 60 had visited New York. 7 had visited Dubai and Wuhan, 10 visited Wuhan and New York, 4 had visited Dubai and New York, while 34 had visited all the other cities other than the above 3. Represent the given information on a Venn diagram. Determine the number of travelers who had visited all the 3 cities, only 1 city, Dubai and Wuhan only. If a traveler is selected at random from the airport, find the probability that the traveler visited 2 cities only. The first question says, represent this information in a Venn diagram. Therefore, we'll draw our Venn diagram. It says that in a survey carried out by the Ministry of Health at Entebbe International Airport, on 150 travelers, then it says that 40 had visited Dubai. Therefore, the number of those in Dubai is 40. Then we have 35 had visited Wuhan. The total number of Wuhan is 35. And 60 visited New York. So we have the number of New York being 60. From there, we have that 7 of them had visited Dubai and Wuhan. So we'll have that Dubai intersection Wuhan will be 7. Then 10 had visited Wuhan and New York. Therefore, Wuhan intersection New York is equal to 10. 4 had visited Dubai and New York. Therefore, Dubai intersection N is equal to 4. And while 34 had visited the other cities other than the above 3. Therefore, the number of Dubai union, Wuhan union, New York, all complement is 34. So we'll go back to represent this information now in diagram, and we'll first let the intersection of Wuhan and Dubai and New York be X. We realize that in our information, this was not given. So we'll state that as X. Then we'll start to fill in our information slowly, starting with the universal, which is 150. Then we'll go to the number of those in Dubai. In Dubai being 40. The number of those who visited Wuhan being 35. The number of those who visited New York being 60. And the number of those who visited Dubai and Wuhan is 7. And that is that part. But we realize that the 7 includes the X number of people. So to find Dubai intersection Wuhan without those who visited New York, we'll have that as 7 minus x. We'll continue to the number of those who visited Wuhan intersection New York. And that section is highlighted there. And we realize that that section still contains an X number of people. So to get those who visited Wuhan and New York, but not Dubai, we'll have the 10 minus X. From there, we'll go on to do the same with Dubai and New York. And in this case, realize that we fill in our Dubai intersection New York without the people who visited Wuhan being 4 minus X. And finally, the people who did not visit any of the 3 cities are 34. So we go ahead to fill in our remaining set, and these ones we shall have the first part where we have 40, which is the total number of people who visited Wuhan, minus, when you open brackets, in this case, to include everything else that has so far been placed in the 40. So we have 7 minus x plus 4 minus x. From there, we'll work out the negative x x, where we continue to 40 into brackets 11 minus x. So we have 40, when you open brackets, the 11, which was a positive, becomes negative 11, while the x, which was a negative, becomes a positive. That is because a negative times a negative gives us a positive. Therefore, 40 minus 11 is 29. So we have 29 plus x, and we feel that in Dubai only. We continue to fill in Wuhan only, and therefore we have 35, which is the total number of people who visited Wuhan, minus 7 minus x plus 10 minus x. From there, the x's will again cancel, so we have the 7 plus x minus x. 7 plus 10 gives us 17, and therefore we shall have 35 minus into brackets 17 minus x. We'll have, when we open our brackets, we'll have the 17 become a negative, while the x will become a positive. We'll continue to have 18. 35 minus 17 gives us 18. So we'll have 18 plus x, which will fill in into our set, and we'll continue to find the next part. So the next part we are finding is n only. And for n only, we are having 60, which is the total number of people, minus into brackets 4 minus x plus 10 minus x. We then go on to have 60 minus 4 plus 10 minus x. That's because the x and the x cancelled out and we are collecting like terms. We then go ahead to have 4 plus 10, which is 14. And when we open our brackets, we have the 14 become a negative, while the x becomes a positive. Finally, we have 60 minus 14, giving us 46. We fill that into our table in our set and we go on. So we've represented the information given to us on the Venn diagram. Our next question said, determine the number of travelers who had visited all the 3 cities. Who had visited all the 3 cities. So first we'll have our setback so that we can look at it and determine those people carefully. We'll start by saying 60, which is the total number of people who went to New York. So we are eliminating that set totally, plus the 18 plus X, plus 7 minus X, plus 29 plus X, plus these 34 people is equal to 150. The 60 plus 18 gives us 78, and for the rest of them, we collect like terms. We then have 148 plus X is equal to 150. Then we have X is equal to 150 minus 148. And finally, our X will be 2. X is the number of people who visited all the 3 cities. Therefore, 2 travelers had visited all the 3 cities. We continue to the next part, which says determine those who visited only 1 city. So we still have the same set coming back. And in this case, we are looking at those who visited only 1 city, being those that are highlighted. That is to say, 29 plus X, 46 plus X, and 18 plus X. We then continue to add them up. So since we know our X is 2, we'll substitute in to our 18 plus X. So we now have 18 plus 2, and do the same for 29 plus X and 46 plus X. So 18 plus 2 gives us 20, 29 plus 2 gives us 31, 46 plus 48 plus 2 gives us 48. The total of all these together is 99. Therefore, 99 travelers had visited only 1 city. We then continue to the other part that says that number of travelers who had visited Dubai and Wuhan only. We'll have our setback again, and then those are the highlighted people. That's Dubai and Wuhan only. That means we're having the 7 minus X. So we'll have that here, and then we realize that our X is 2, so we'll have 7 minus 2, and we'll get 5 as our answer. That means 5 travelers had visited Wuhan and Dubai only. These people who visited Wuhan and Dubai only did not visit New York. Finally, part C, which says if a traveler is selected at random from the airport, find the probability that the traveler had visited 2 cities only. We're looking at our set again, and we are realizing those who had visited 2 cities only are those who fall under Dubai and Wuhan only, Dubai and New York only, and New York and Wuhan only. That is to say 7 minus X, 4 minus X, and 10 minus X. So add these people up as shown, and we'll substitute the X with 2. So we end up having 7 minus 2 plus 10 minus 2 plus 4 minus 2. We have 7 minus 2 giving us 5, 10 minus 2 giving us 8, 4 minus 2 giving us 2. And that gives us 15 for the total number of people. Yes, Isaac? Okay, may I finish this slightly and then get the questions? So the total number of travelers who had visited all 3, the total number of travelers in this case that they sampled 150. Therefore, the probability will be 15 out of 150. When we reduce this, we get 1 out of 10. Any questions? Someone in the chat asked, what if they said at least 2 cities? At least 2 cities that you have either visited 2 cities only. That means a person who has visited 3 cities qualifies, because at least means the least number of cities one should have visited. Therefore, in this case, if it's at least 2 cities, this person should have visited 2 cities and more. So you in this case, we would have included the X. Any other questions?
In case you have a question, raise up your hand. Any question concerning sets, raise up your hand. We can handle it from this point.
Yes, please, Mark.
Shalom. I was trying to ask you, why are we using, if they're saying that travelers who had visited 2 cities, why are we using all the, okay, why are we using N intersection, D, I mean D intersection W, W intersection N, and then N intersection D? Why is it like that?
The question said that travelers who had visited 2 cities only. They did not specify the cities. If we are looking in this case, those who have visited Dubai and Wuhan only have visited 2 cities. That is to say Dubai and Wuhan. Those who have visited Dubai and New York only have visited 2 cities. That is to say Dubai and New York. And finally, those who have also visited Wuhan and New York have visited only 2 cities. Therefore, they also qualify to fit into that category. That's clear. Joy?
Yes, my question is, I'm requesting you to repeat how you got the ones that visited all the cities.
All the 3 cities.
Yes, thank you.
Oh, God. Okay. For those who visited all the 3 cities, I say that instead of us writing 46 plus x plus 4 minus x, instead of us typing 46 plus x plus 4 minus x plus 10 minus x, we could instead have this whole set, since they said that the number of those who visited New York is equal to 60. We are realizing that all those things that I've mentioned, 46 plus x, 4 minus x, 10 minus x, fall under those who visited New York. Therefore, for this whole entire part, we shall say 60. Then we'll add on those that would have not been part of the 60. And that will be the 29 plus x, 7 minus x, 18 plus x, and the 34. And all these will be equal to 150. From there, we'll go on to add our totals, and we'll find out that the number of those who visited all the 3 cities is 2. Joanna, is that okay?
Yes, thank you.
Welcome. Dennis? Dennis?
Yes, please. I'm saying that what they say at most 2 cities.
Pardon?
What if they also visited 2 cities?
Dennis, is it okay if you type your issue in the chat?
Okay, let me.
In the chat, Maria asked if n into bracket, the number of those, for example, who visited Dubai, intersection, those who visited Wuhan, intersection, those who visited New York, all complement. Is it similar with the number of those who visit, or if they say that those who visited Dubai complement, intersection, those who visited intersection, those who visited Wuhan, intersection, those who visited New York, are they similar? I don't think so. I think the first one where you said those who visited Dubai, intersection, those who visited Wuhan, intersection, those who visited New York, complement, means that that the D intersection U intersection N intersection, it means that you do not touch the middle part, because D intersection W intersection N is complement, is this part, and when we say complement means you do not touch it. So I think it's just that area. While when we say D intersection Wuhan complement, already the intersection being on set D, I understand it as do not touch set D. And then you continue to not to touch W and N. So I think the two are different.
Yes, you are very right, Joy. They are totally different things.
If they're Joanna, Joy. Joanna.
Joy, have you answered at most 2 cities? Someone had a question. What if they ask at most 2? Can you put more emphasis on at most and at least, those 2 words?
At most means that the most number of cities this person should have visited is 2. That means that someone who has not visited any city, one who has visited 1 city, and those who have visited 2 cities qualify in this category. While when we look at least means that the least number of cities this person should have visited is 2. So for at least, we are moving from 2 to 3 to 4 to 5, like that. So in this case, so in the case where we have at least, we are basically dealing with greater than or equal to. While with at most, we are dealing with less than or equal to.
Okay. Hope everyone's question has been answered. In case you have a question, leave it in the chat. Thank you so much, Emilia. Joy. Joy, do you have any other question?
Yes, I do.
Okay, we can continue.
Mr. Kaziba?
Yes.
Is it okay if someone else first presents?
Okay, it is very fine. Okay, thank you so much, Emilia Joy, for taking us through sets. Those having any question concerning sets, please leave them in the chat. Joy will be able to answer. Arthur, are you ready?
Teacher?
Yes.
Someone requested that I repeat at most 2 cities. At most 2 cities means less than or equal to 2 cities, meaning this person could have visited 2 cities, or could have visited none of the cities. That's what most means. It means you can either take 2 subjects, 1 or not all. Is that okay?
Yes, I think it is very clear. Very, very clear. Okay. Thank you so much, Emilia Joy for taking us through at most and also taking us through sets. I hope now everyone has really understood the meaning. Judith, those things are not the same. D union W union N is not the same. Okay, okay. When you put the complement on the intersection, then they mean the same. But I don't know. Judith, write it very clearly the way you want it. But the first one you asked whether union W union N intersection, those two are not the same. They are not the same things. Okay, allow me now to invite Arthur to take us through his presentation. You're most welcome.
Thank you. Let me get the gadget that I'm getting the gadget I'm going to use for presentation. Just in a second. Still loading.
Recording in progress.
So as requesting if you could make the other Arthur Shalom a co-host. I don't know if it can oh yeah, thanks. So let me start right now. So my name is Arthur Shalom, and I'm here to present to you these two seminar questions, which is number 11 and number 13. So number 11 it's about matrix and vectors matrix. So now given that 2 into brackets m, given that 2 into brackets m and 2n plus a quarter into brackets 4 and m minus 4n, close brackets is equals to 9, 7. Determine the values of m and n. That's part A. And part B is use the matrix method to solve negative y plus 3x equals to 2, and also 3y minus 2x equals to 1. So when we go to part A, we rewrite the equation, and we shall have 2 open bracket into brackets m and 2n plus a quarter then into brackets 4 and m minus 4n equals to 9 and 7. So now we multiply this with this and shall get to n to 2m, and then the 2 with the 2n shall get 4n. So and then the quarter, when the quarter multiplies with the 4, you get 1. This m minus 4n shall get m minus 4 out of 4, which is going to be equal to 9, 7. So now we can use this, the top part. We can use this and this to find the value of m, where we shall get 2m plus 1, which is equals to 9. And then we shall later get m as 4. So now that we have m, we can find n. So now we say 4n plus we use this equation here, which is 4n plus n minus 4 out of 4 equals to n. So I shall say 4n plus 4, sorry, 4n plus m minus 4 out of 4 equals to 7, and shall replace the m with the 4, and then we shall later get 16n minus 4n, where it is equal to 7 times 4, because like, let me get a pen here, because like when you reach here, we get 4n, and okay, like we multiply 4 on every part here, 4 here, multiply 4 here, multiply 4 here. So now multiply 4 on everywhere, we shall get 16n plus 4 minus 4n equals to 7 times 4. And then the positive 4 moves to the right hand side, which will become a negative, and like we shall get 12n, which is equal to 24, because 7 times 4 is 28, minus a 24 we get 20, sorry, minus a 4 we get 24, and then like divide 12n, sorry, divide 12 on both sides, and shall get n as 2. That's part A, but like I'm seeing very many chats asking me to repeat or something like that. So let me repeat. Let me repeat exactly from the beginning on this part here. So we have the numbers 2 in 2 brackets, m and 2n, plus a quarter, which is 4, and m minus 4n, which is equals to 9 and 7. But now we see that to find m, we can use these two parts here. But the only way we first have to calculate the equation, and what we do here, we first multiply these 2 with the m and these 2 with the 2n, where we shall get 2m and also 4n. And then it's a quarter, we multiply with 4, where we shall get 1, and the other quarter multiplies with m minus 4n. Let me zoom on my letters. Okay. Let me increase my letters. So how about now? How is my, I guess my letters are a bit bigger. I hope it's fine with you guys now. So as I was saying, we go back to the point where I was saying that 2m and 4n, because when we multiply a 2 to this, we get 2m, and multiply this 2 to this 2n, we shall get 4n. So we get 2m and 4n. So like we now add the quarter to the 4, where we shall get, sorry, we add this other equation, but we have to first calculate it. So we shall say a quarter times 4, and we shall get 1, and then on the upper part, and then on the lower part, we shall get a quarter times 4 minus 4n, where we shall get m minus 4n out of 4. So which is going to be equal to 9, 7. So now what we do, we use this upper part of the matrix, which is 2m. We have 2m here, we have 1, and we have 9. So we shall say 2 plus 2m plus 1 is equals to 9, using the upper parts, and shall get m as 4, because 2m, we shall now take the 1 to the other side, and shall get 2m equals to 8, where 2m is equals to 8, and then we shall divide both sides by 2, and we shall get 4. So yeah, now we have got m as 4. Now that we have m, it's very simple for us to get the other one, the n. So now the way we get n, it is like we say 4n plus, we use the lower side, which is 4n. Sorry for the noise. Okay, why should I repeat from? Okay, I'll get questions after my explanation. So 4n plus m, we use the lower bit, where shall the lower line to find n, because that's where that's the position of n. N is in the lower line. So now we say 4n plus m minus 4 out of 4 is equal to 7, where we shall get 4n plus the 4 plus the m. M is replaced because we got it as 4, so it becomes 4. So we get 4n plus 4 plus this 4 here plus this 4 minus 4n out of 4 is equal to 7. So now here you multiply all sides by 4, and here we get 16n. Here we shall get 4 minus 4n, and here we shall get 7 times 4, which is 28. But now you see this, when we reach here, 16n plus the 4 goes to the right hand side to collect the like terms together, and then which will become a negative. So you get 4n, so you get 16n minus 4n equals to 28 minus 4, where 28 minus 4 is 24, and 16n minus 4n is 12n. So 12n is equals to 24, and then n we shall get it as 2. So that's the m and the n. But now let me go. Okay, let me wait for it's first tell me your questions, please, because like I've been getting a lot of questions in chat. I've repeated many times. I don't first understand what the problem is, or like the blank space what I'm missing in the explanation. Juko, what are you saying? I can't hear anything, Juko.
You now hear me?
Yeah.
So you mean to say that this 4 in the bracket of 2m and 4n divides the entire bracket of m minus 4n divided by 4?
I beg your pardon. I'm having background noises, but I beg your pardon.
Okay, you mean to say that the 4 in the bracket of 2m and 4n, you get it? Multiplies the entire bracket of m minus 4n divided by 4.
You mean this point here?
Yes. Can you pull a bit higher where there is 2m, the very first bracket of 2m divided by 4n?
2m. Oh, you mean here?
Yeah, yes, there.
Okay. So what do you want me? Okay, you want me to explain to you how this was got?
yeah, I wanted to know whether that 4n multiplies the entire bracket of m minus 4n divided by 4.
Yeah, so these two multiplies with this up bit and also multiplies with here. Let me show you how it looks like. So you open brackets after having such an equation. After having this, you take it to this 2 times m. I didn't put that step there, but then
Okay.
it's supposed to be like that. 2 times m and also 2 times 2n.
Okay.
Which will lead to, because you multiply everything that's in the brackets with what's it called? With a scalar quantity, with a 2. So now we shall get 2m. Okay, with a scalar, I don't know, with that digit outside. So we shall get this as the answer. After having this, so this multiplies the up part and also the lower part. So have I answered your question? Jiko, have I answered your question?
Yes, you have answered my question. Thank you.
Okay. How about MAK? MAK has a question. What's your question, MAK?
I was asking that this, is it 1 out of 4? Why is it that when you came to the second step of saying that 2m and brackets then plus 1 open brackets 1m minus 4n and then 4, why is it like that? I thought it had to be it is 4 times the outside number and then still m minus 4 times the outside number, which is a quarter. Why isn't it like that?
Why isn't it like, I beg your pardon, on your, what you think, on why isn't it like how? Why isn't
Okay,
it like?
I thought that when you were talking about the bracket of 4 minus, okay, like a quarter open brackets 4 then m minus 4n, I thought it had to be that 1 over 4 times 4 and then you slope down and then you say m minus 4n times 1 out of 4. Why isn't it like that?
It's like that. It's just that I skipped a step. Let me show you. Let me show you. Let me show you. So you see it? When you come here, let me just show you how I got my one as the answer. So this quarter multiplies with this. This whole figure multiplies with that, and then it also multiplies with it, as you say. So we get this. And also here we get a quarter times my m minus 4n. Sorry about the handwriting. So now this 4 goes, and also this 4 goes. So we get 1 here. And then this one we shall get m minus 4n out of 4, as you have said. So I guess it's I guess it's yeah. Is it clear now? Hello. Okay. MK, MK, are you still there? Because I think I've explained it, but you're not coming back to me. Excuse me. Okay. Let me go to. Is anyone else with a question? Okay, let me check chat. Okay, guys, I might continue to the next part B, because I'm not getting any questions. But in case you have, you still have you can still ask. Isaac, what you saying?
Hello. Hello.
Yeah, speak.
I was asking that, can we use mathematics? Is it possible to use matrix method to solve that?
Yeah. No, it's not. It is not why you apply matrix method. Like in this number, like I don't think you're supposed to apply matrix method. You just go straight to the answer. Just go straight. Like matrix method is part B. Like using energy to inverse like that. But like in part B, you don't have to use matrix method. So let me go to part B. So in part B, they say use a matrix method to solve that equation. So with this, we see that we have this negative y plus 3x is equals to 2, and 3y minus 2x is equals to 1. Oh, Isaac, do you still have a question? Isaac?
Sorry, I don't have any question.
Okay, so let me continue. So we have this matrix equation, simultaneous equation, and like they have told us to use matrix method to solve it. So what we do, we have to use matrix method, but now we have to form it into a matrix. So what we do, we say -1, because this is a -1, and also here +3, and then here goes 3, and also here -2. We close brackets. Then we say y because it's the first, and then x because it's the second, and then 2 and 1. But now how we prove that this is correct? We go to if we want to know that this matrix equation that we have put here is correct, we say this times this is -y plus 3 times x is 3x, which is equals to 2. And then I hope it's clear, but you will ask questions. So then 3 times the y is 3y. We're just proving that whether this is correct. Then -2 times x is -2x, which is equals to 1. So I see that we have the same equation as this here. So I think this is very correct. So now let's continue. So we have our matrix equation, and now we have been told to use matrix method. So now I decided to use a method which has adjoint. So now an adjoint, we find it like this. It is the major diagonals. Okay, so the major diagonals are 10 positions,
Which one? No.
The major diagonals change positions and the minor diagonals change signs. So these two change positions and these ones become negative. And so this is the adjoint. This is the adjoint. Sorry, that was too exaggerated. Let me. So this is the adjoint, which we multiply in this equation. We put the adjoint here, multiply it here, and also multiply it here. So we get it's here and here. So we multiply the adjoint on both sides, and here we shall get I've forgotten the equation. The matrix that is called. It's some matrix that it's called something. But what is its name? But it is like okay. It can examples can be like this. Sorry, this is 0, then this is 1. So this is this kind of matrix. I've forgotten its name. But anyways, let's continue. So now when you multiply an adjoint to an original matrix, you will get something that is some specific kind of matrix. And for us here, we shall get -7 and -0 and 0 and -7. But now let me show you how we get this. How we get it is like these two, -2 times -1, we get 2, plus this -3 times 3, we get -9. So now this -3 times this -1, we get -3, plus this sorry, plus this -1 times this 3, we get -3. Yeah, it's called the identity matrix. Thank you. And so now we go on the other side where this -3 multiplies with this 3 where we get -9, and then this -1 multiplies with this where we shall get 2. Oh, sorry, no. See, I'm making mistakes. Sorry, guys. So it is this one that multiplies with this also. So you say -2 times 3, where we shall get -6, and also this -3 times this -2, where we shall get 6. And then here we shall get -3 times 3, get -9, and -1 plus times -2, we get 2. So we shall get -7 here, 0, 0, and -7, which will multiply with this. And then also this one, we also do the same, where we shall say this times this is -2 plus -3 times 1, I shall get -3. Sorry, this is supposed to be, say, so first give me a second. So we say -2 times this, you get -4 plus -3, because this -3 multiplies with this one, and then this -3 multiplies with this -2, we get with this +2, we get -6. This -1 with this this positive 1, we get negative 1. Now we shall get negative 7 and out and negative 7. And yeah, so we shall now do the same thing here. We use the upper layer, which is like this. So now when we use the upper layer, we are going to first have to merge this into give me a second. So now we shall have to say negative 7 times this y, we shall get negative 7y plus 0 times x, which is 0, equals to negative 7, like here. And then shall end up getting this, which is later equal to 1, because it divides both sides by negative 7 and y is equal to 1. Now, I hope that's clear, though I haven't been so, I feel like I haven't been so clear in this explanation. I'll be waiting for the questions. So we continue to get x, and x is got like this. You say 0 times y is 0 plus negative 7 times x, which is negative 7x, equals to negative 7. Now we get negative 7x equals to negative 7, and we shall get x as 1, because we divide both sides by negative 7 and get x as 1. So, Julie, what's your question?
Finally captured. Actually, I captured. Me. You want those too, huh? You no idea.
So, anyone with questions? Anyone with questions? Okay, so
okay. Thank you so much, Arthur. I want to throw some light. Some people are getting a bit confused. Would you allow me to share my screen briefly? Your method is very okay and the answers are right, but people have some questions maybe, okay? Let me share my screen. Now, when we are attempting the matrix method, we have two methods that it depends on how the teacher is handling. So what Arthur has done is very right. Now, the first method, like what I want to emphasize is the arrangement. Now, our equation was negative y plus 3x is equal to 2 and 3y minus 2x is equal to 1. So always you must make sure that the equations, the way they are appearing, if at all the first variable here is y, then also in your second equation, the variable here must be y. In case you find that in the second equation, the order of the variables y and x. In case you find that they are not in that order, then please you must make sure you write them in that order. So when you are extracting your matrix that you are going to use, you are noticing that this is y first, meaning that also here, this matrix of variables, it will start with y and then x. So meaning you have your negative 1, 3, 3, negative 2 is equal to 2 to 1. Then those people who are getting negative 1, your challenge came from here. You interchanged. There is something you didn't do well and you interchanged. So for you, when you came here at this point here is where you interchange. Instead of beginning with y, for you started with x and y. That's the arrangement of variables was x. So that is why you made a mistake. But in case you wanted to write x and then y, it means that you would have changed the order of your equations and you start with 3x minus y is equal to 2. Then the second equation would be negative 2x plus 3y is equal to 1. Once you arrange them in that format, then you negative 1, negative 3, x, y equals to 2 to 1. So it depends on how your equations are arranged. So don't anyone getting x is equal to negative 1, y is equal to negative 1. Your challenge came from how you arrange your variables at this point, because most of the questions you have been finding, they were beginning with x and y. So for you, took it in that perspective that always you begin with x and y. But always what matters is how your equation is being arranged. Number 2, people are talking about the getting determinant, getting the inverse. That is another, let me call it a longer route. I understand that when you are obtaining, when you are getting the inverse, in some of the schools, they will teach you that get the determinant, get the inverse, and so on. Then you multiply, which is very okay. Now, those people who want to use that approach, now you are going to notice is that getting an inverse and multiplying it on both sides, you are wasting your time. What matters a lot is you obtaining the adjoint. Adjoint is the most important thing. So for that case where we had negative 1, 3, 3, negative 2, yx is equal to 2 to 1. So in case our adjoint, we know very well that to get our adjoint, we interchange the elements we have in the major diagonal. We come and interchange these elements. So this will be negative 2, negative 1. Then here in the minor diagonal, we change the sign. So you have negative 3, negative 3. Meaning that now when I'm obtaining my determinant here, you'll have your determinant as it will be negative 2 times negative 1 minus 3 times 3. So you end up with 2 minus 3 times 3, which is 9. 2 minus 9, you end up with negative 7. So meaning that now you are going to end up with your inverse. Let me just call it maybe A inverse as 1 out of negative 7 into negative 2, negative 3, negative 3, negative 1. So that will be your inverse. So meaning, remember, you have to multiply, to pre-multiply, in fact, pre-multiply the inverse on both sides. So when you look at now, let me go back here and okay. So when you come back here, when you are multiplying your inverse, you'll have 1 out of negative 7 into negative 1, 3, 3, negative 2 into yx is equal to negative 1 out of 7, negative 1, 3, 3, negative 2, and then 2, 1. So when you notice, you are going to notice that now this 1 out of negative 7 here is the same thing here. So these ones can easily cancel out. So what you are going to remain with is negative 1, 3, 3, negative 2, yx equaling to negative 1, 3, 3, negative 2, 2, 1. And when you look at what you have remained with, this is the adjoint, and this is the adjoint. So when you are working with the matrix method, for you getting the inverse, you are taking your time. You are taking your time. But as long as you multiply by the adjoint, you pre-multiply, it comes before. As long as for you multiply on both sides, then it becomes very okay. There is something I've forgotten here. There's a matrix I have not written here, but you write it there. So it is just a matter of you multiplying by the adjoint on both sides. So you may not need for you to multiply with what? You may not need to multiply with the inverse. But in case that is how you were taught, you can take it on like that. But for cases, we have noticed that students who are multiplying with inverse at times find it hard to deal with Whenever you find yourself having a fraction and your inverse, and it becomes very hard for you to multiply, and you end up failing the number. Yet it's just because you did not do it rightly, or that you wanted to use it. So you can either ignore it or you take it away. But the best is to multiply with the adjoint. No need of you waste time to multiply with the inverse. Then some people were confused, but please need to know how. Okay. Let me ask you to mute some people. Okay. Some people were confused with how we deal with a scalar. Remember, when you have any matrix, any column matrix, and you are multiplying with a scalar, a k, this k always affects the first digit. This k affects the second digit, as Arthur has been telling us. So meaning you will get ka and you will get kb. So the k multiplies both numbers. Even if you have a half into maybe 2, 4, still this a half is one number, is a scalar, one digit. So meaning you have a half times 2, then a half times 4. So it affects all. So here, this is where you just reduce by 2, 1 by 2, 1, by 2, 1 by 2, 2. So you end up with your 1, 2. So always pay attention to that scalar. Then there is something I think I need to allow me to also bring it at this point. The one about sets. Some people were still confused when it came to sets, but allow me to throw some light when it comes to sets. Okay. Now, when it comes to sets, someone was confused about two sets, what you called A, it was when you have A intersection B complement. A intersection B complement means that in case I have two sets, this is one set and this is set A and B. So the first thing you need to look out for is what is A intersection B. That A intersection B is this middle part here. However, complement means anything outside that. So meaning that now that region is this region that is outside that complement. So that is the region that you are looking for. When it comes to A intersection B, all of it complement. Then when they say A, in case we are on theory, A intersection B intersection C complement, still this is the complement, this is the intersection of all the three. So the outside region is what we call the complement. So that is how you do it. So that is what I wanted. So you need to know the difference between those different words. So that is how you write and you go about it. Okay. Arthur, you can continue.
That was the end of my question. I have a second question, but I'd like someone to present before I present again.
Okay, okay. Someone is asking, can I use the method of cancelling the inverse when told to solve using the inverse method? They will not tell you to use the inverse method. We don't have an inverse method. We only have matrix method. So the question will always be specific that use the matrix method. So they don't specify that whether it is inverse or what. No, they always specify it as matrix method. We don't have any other method called the inverse method. Yes, then someone is asked, so when the equation, yes, so when the equation is starting with y, then start with yx. In case it's starting with xy, then start with x and y. Okay, okay, thank you. And then also when they talk about a singular matrix, please always note that a singular matrix is one that does not have a determinant. So its determinant is 0. So the moment you hear something concerning the singular matrix, what has to come into your mind? That the determinant is 0. At times, in case they don't use the word singular matrix, they may use that the matrix has no inverse. So when you hear that the matrix has no inverse, when they say A, B, C, D is a singular matrix, it means that if at all it is singular, its determinant is 0. When they tell you that the matrix doesn't have an inverse, it also means that if at all a matrix does not have an inverse, it means that its determinant is also 0. So keep on looking for those words, singular matrix, or when they tell you that the matrix has no inverse. So when the matrix has no inverse, it means that you cannot obtain its determinant, because to obtain our inverse, always we get the adjoint divided by the determinant. And for only we cannot have an inverse and when the determinant is 0. So that is the only case. So in case the determinant is 0, it means that you cannot divide anything by 0. So that is when our matrix has no inverse. So those are the two common words they will be using, that the matrix is a singular matrix, the matrix has no inverse. The moment you hear the word, what you need to do is at times they bring those questions in this format. They tell you that maybe x2, then they put 3, and they can put maybe, let me say this is x minus 2, they put here 4. And they tell you that matrix A is equal to that, and it has no inverse. So find the value of x. So meaning for you, just come multiply your major diagonal, say 4 into x minus 2, then minus 3 times 2, and then equal to 0, and so for x. So those are the special cases that they'll always be asking for. Okay. When they say A union B union C complement, that is the outside region. That is the outside region. Okay, they are not, Patricia, they are not the same. They are not the same. Let me first draw that thing again here, such that we understand those 3 regions. Okay. Sorry. Okay, let me just do. So the 3 regions you need to understand when it comes, in case this is my set, let me say this is A, B, and this is C. Let me name this one 1. I name this one 2. I name this 3. I name this 4. I name this 5. I name this one 6. This one 7. And this one I can call it 8. So 8 is given as A union B union C complement. So that is region 8. 8, this outside one, is the one called A union B union C complement. Then when you say A intersection B intersection C complement, it means the outside region. So it means everything here outside, it has 2, 5, 4, 7, 3, 6, and 8. That is A intersection B intersection C complement. Then when they tell us, when you look at the first region, here number 1 is what we call A intersection B intersection C. When you look at number 2, this region here, it is the region we call A intersection B intersection C complement. When you look at region number 3, this region here, you are noticing that which one is exclusive is B. B is not there. So meaning it is A intersection B complement intersection C. When you look at region number 4 is A complement intersection B intersection C. When you look at region number 5, this region here, you are noticing that we can have it as A complement intersection B complement, A complement intersection B intersection C complement. That is that region. When you look at number 6 is A intersection B complement intersection C complement. When you look at region number 7 is A complement intersection B complement intersection C. And then our 8 is A union B union C, but all of it the complement. So those are the few regions, or those are the regions that you need to understand. Then in case we are on a two, when they are on a two diagram, when they say intersection B, all of it complement. Okay, I think we can. So you need to know those different regions, and I think we shall keep on emphasizing, and we shall try out a number on how. Then what you want to, another important property I think you need to know now is the one you are trying to mean is when we have, when I have A union B complement, this is the same as N A intersection B complement. Those ones are the same. So that is an important property. Or when you have N A complement intersection B complement, this is the same as A intersection B complement. So these are the ones that you are trying to confuse the two. So these ones are the same. So you just need to know which one is which. So you can take this one to when it comes to 3. I think this is the one you are trying to mean. So when you have A complement intersection B complement, this is the same as A union B, all of it complement. In case it is A complement union B complement, it is the same as A intersection B, all of it complement. And these are what we call the we call them the De Morgan's laws. The De Morgan's laws. So that is what you are trying to mean when it comes to a 3. So for a 3, in case it was a 3, it means A complement intersection B complement intersection C complement is the same as A union B union C, all of it complement. So those are the same. Okay, hope now it is very clear. Darwin, hope you have got that. That A complement intersection B complement intersection C complement is the same as A union B union C, all of it complement. Then someone is asking, what is A complement intersection B complement and A intersection B complement? Okay, that is the last one. Let me, now when you look at those two, the two you are asking, in case I take them to Venn diagrams, in case this is my A and this is my B, when they tell me A complement intersection B complement, and when they tell me A intersection B complement, all of it complement, it means A intersection B is this region here. Then complement means anything outside that. So that means anything outside this. So that is what you call A intersection B intersection C complement. Then when they tell me A complement intersection B complement, A complement is this outside region, because we have said is the same as A union B, all of it complement. So it is here, is what we call A intersection B intersection B, all of it complement. Hope it is, when they say A complement intersection B complement, it is the outside, is the same as A union B, all of it complement. So A union B is this region. Then anything outside it here is what we call A complement intersection B complement. Hope it is now very, very clear. Okay, then. Okay, oh, then someone is, I think what we are trying to ask, I think, is A union B. So when they say A union B just means that thing inside. Okay, let me first remove this. In case they say A union, sorry, okay. In case these are your two Venn diagrams, and this is AB, A union B is this one, is what we call A union B. That is A union B. I think that's what you wanted to mean. Okay. Thank you so much. Let me first end here. Emilia Joy, are you ready? Okay. Joy, are you ready to take us through your second number?
Mr. Kazima?
Yes, Joy.
Unfortunately, my laptop where the number is shut down due to power. So I was hoping I could notify you when I'm ready.
Okay, okay. It is very fine. It is very fine. Okay. Arthur, would you take us through the second number? Arthur, okay. Do we have any other person who has a number to present? Any person who has a number in case you have prepared the number you want us to discuss? Are you there? Okay. Yes, Patience. Let me give you the co-host rights. Patience, go on and share your screen. Patience, unmute. Okay, guys, Patience. Oh, okay. Kengazi, Patience, unmute. Okay. Okay. It seems Patience is not. So now we are going to go on to we are going to start doing questions. So let me ask everyone to get a pen, get your calculator, and then we start. So we are going to be doing the numbers and then we share the answers in the chat that we are getting. So we are going to be doing different numbers from the different questions papers. Kenganzi, I'm failing to get you. So I'm going to be displaying the number and then we start on the number. Then after doing the number, we shall share our answers in the chat. And then in case there is any challenge, then we shall discuss it together. So the first number I want us to do is going to be this number 1. So everyone get your calculator, get your pen. We are going to give ourselves 4 minutes for this number. Every number in section A, we must use 4 minutes. So we are going to give ourselves 4 minutes and we do the number. Then after we share our answers in the chat. In case someone is getting some challenges, then we shall do it together. So can we start on number 1? Get your pen, get your paper, and then start on number 1. Then after we share our answer in the chat. So we are giving ourselves 4 minutes to do the number. So we remember the paper is for 2.5 hours. So we need to know how to time ourselves very well. So we are doing number 1. So we have started. Everyone must be doing now, not to just listen in. When you finish, post your answer in the chat. When you finish, post your answer in the chat. When you finish, post your answer in the chat. Post your answer in the chat, then we do it. Very good. Everyone is working out. Number one. We have 2 minutes to go. We have 2 minutes to go. So please, let's finish. Okay. Very good. Okay. Okay. Post both answers for part A and part B. Very good. Okay. 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 Please post your answer you are getting. Thank you, Dalton. Thank you, Asenath, Sadiq. Moses Okelo, check on your answer. Lena, check on your answer. Abiola, check on your answer. Moses Okelo, Shatra Kisache, check on your answers. Michael Henry, very good. Asenath. Okay, I think now our minutes are done. We are going to do it together. Okay, Patience, let me ask you to mute. Okay, we are doing it together. Those who are not, our correct answers are 23 and 590.5. Anyone getting those answers? You are very correct. Mark yourself. What are the key things you need to know? One is that when I look at this, always look at your definition, M and N. So this one is your M and this is your N. Meaning that when you look at the definition of M and N, substituting the way it has been defined. So you have 2 asterisk -3. So for this case, your M is 2 and your N is -3. So meaning that when you come here, where there is M, substitute 2. Where there is N, put -3. So we shall say that 2 asterisk 3, -3 is equal to our M, which is 2 minus -3 squared plus 3 into our M, which is 2 over -3. So we shall come on and open our brackets. What are you noticing? That this is a negative and a negative, which gives us a positive. So we shall have 2 plus 3 squared plus. When you look at this is a 3, this is a fraction. When I open the brackets, I'll have 3 times 2 out of -3. So we shall end up with 2 plus 3, which is 5 squared plus. When I come here, this 3 and this one can reduce. So I remain with the 2 out of -1. So 2 out of -1 is -2. So I remain with -2. So 5 squared. 5 squared means 5 times 5. And now some of you, those who are getting, I think 8 is for you, have put it as 10. So plus -2. So which gives us 25 minus 2, which gives us 23. So anyone who is not getting 23, please check it out. Then when you look at the second part is 2 asterisk -3. So when I try to pair this, you have already obtained the answer for 2 asterisk -3. Which answer? We have it as 23. So here, the whole of this, we can substitute our 23. So meaning that now we shall have 23 asterisk -2. So when I come back here, so you check out those who are not getting, you'll tell me. So meaning that now we shall have 23 asterisk -2. So your M now is going to be 23 and your N will be -2. So now you substitute back into your original expression, which was M asterisk N was M minus N squared plus 3 into M out of N. So you substitute your M, we shall have 23 minus -2, all of it squared, plus 3 over. Our M is 23 out of N, which is -2. So you work out what you have in the bracket. Negative and a negative will yield a positive. So you shall have 23 plus 2, all of it squared, plus you can also open, say 3 times 23 out of -2. So this is 25 squared plus this is going to be 23 times 2, 23 times 3, which is 69 out of -2. So feel free here now to use your calculator and say what is 25 squared, and you get your answer as 625 plus 69 divided by -2, which is -34.5. So we end up with our answers 590.5. So that is how you do it. Unless someone has a question. Yes. Okay. Yes, the 3 in the bracket only affects M. Yes, now like you need to know when you are opening a bracket, a fraction, when you are opening, let me say in case you have 2 and you are multiplying it times a half like this. This 2 only affects the upper, but don't confuse it with matrix A. Whenever there is a slash, it shows you it is a fraction, and only it will have an effect on the numerator, not on the denominator. Okay. Then what if you get the LCM? That one is also very fine. Those who want, you would have gotten the LCM now. In case you were getting the LCM, meaning you have 625 plus 69 out of -2, which you could as well write it as 625, 69 out of 2. So your LCM here is 2, and then you have here 1. So you just get your LCM as 625 times 2 minus 69 and obtain your answer. Still, that one would be very fine, no problem, and you will not be penalized. So that was also very fine, and you would remain your answer 1181 out of 2. Okay. Okay. I think now it is clear. Good. Yes, Monica. Monica, ask. Monica, unmute and ask.
Excuse me, sir. What if in part B, this other -2 was given to us first, like as in the brackets when it's the first in part B? How do we do it?
Can you tell me what to write? Tell me what to write. Like, I want to use an example.
Like -2 star into brackets 2 star -3.
Yes. Now, since you had this one already, you substitute it. You say -2 asterisk 23. But you go back to your definition that this is M asterisk N. So for this case, this is your M and this is your N. So your M will be -2, your N will be 23. Okay. Okay. Hope that is clear. Let me check.
Thank you very much.
Okay. Let's go to the...
Yes, sir.
Okay. Now the next number we are going to do is going to be a number on functions. We are going to go into paper 2. We do a number of functions. Why? Because this is a number. Like it or not, it's going to appear in your papers. So that's why we are going to first do compulsory numbers. So we are going to try out a number in paper 2 as well, a number concerning functions. So we are going to do 2 numbers. When it comes to functions, you'll find a number in section A and you'll find a number in section B. So can we go to number 7? Is the first function number we have found. Functions. Let us do it. We are using still 4 minutes to do it. We are using 4 minutes to do it. we are using 4 minutes. So let's do it. Okay, those who are finding them hard, first try. Mark, let me ask you to first try. We are doing functions. We are using 4 minutes. We have 3 minutes left. Very good. Just sending in the answers. Okay. I've already seen Lena. Thank you so much. Okay, Lena, thank you so much. Even the rest, thank you so much. Angel, Fiona, Mika Masi, Zipelia, Jessica, Sharon, Emilia Joy. You're going to share with us how you're getting a half. 0.5 Dalton. Okay, I think the 4 minutes are done. I think the 4 minutes are done. So we are going to do it together. Okay, let me share my screen and we do it together. Those who are still doing, just know if at all you are still doing, it means that you'll not be able to complete the paper because you don't know how to keep time and you have not budgeted very well. Once you look at a number, you try the first time, it's not coming out, it means there is something that is not right. Okay. Very good. So this is our function. They are telling us that our function, I'm saying, okay, very good. I'm saying correct answers now coming in. They are telling us that our function f of x is equal to 0. What does it mean? Let me first write here some side work because I'm saying some answers that are not right. Okay, when they tell me, imagine I have, imagine they have given us our function f of x is equal to, let me say, 1, let me say a out of x plus a, maybe plus b. When they tell me that my function is equal to 0, it means that I will equate the whole of this function to 0. It means I would say a out of x plus b is equal to 0. So when you look at this function, what does it mean? Where it means that which value, which when you substitute into your function, you come up with your answer as a 0. So the first thing you have to work out, first remove this denominator here. How do you remove it? Multiply it both sides, multiply it this side to remove it. That is the first thing you do. That is the same thing we are going to do here. So we are going to equate this function to 0. So I'll have x squared plus 4x plus 3 out of x squared minus 7x plus 6 is equal to 0. Equate everything to 0. So now the next thing we are going to do is we are going now to equate to 0 and we'll remove the denominator. So we are removing this one, meaning I'm going to multiply this side by x squared minus 7x plus 6. Multiply this side x squared minus 7x plus 6. So when you look at it very well, you're going to notice that this and this are going to cancel, and any number multiplied by 0, you end up with a 0. So meaning you are going to remain with x squared plus 4x plus 3 is equal to 0. And when you look very well, this is a quadratic equation that they want you to solve. So anyone who has been getting a half, 1, it means that you have not solved the equation very well, or there is something that confused you, that it did not come out very well. So now what are we going to do? This is quadratic equation we are going to solve. So when we are solving, you can use any method of your choice. You can use the factoring method, you can use the bulldozer, you can use the completing squares, depending on any method of your choice. But I feel we may not need to go through it. Okay, but I think maybe let me use the factoring method, factor. So here we are going to look at for two numbers, which when you multiply, you get 3. So our product must be 3 and our sum must be 4. Can you type in the chat quickly? Which two numbers, which when you multiply, you get 3, you add them, you get 4. Type in the chat, any two numbers, which when you multiply, you get 3, you add them, you get 4. Type in the chat quickly and we'll see whether we know those two numbers. Very good, very good. 3 and 1, very good. So meaning those are the two numbers that we are going to use. So we shall use our 1 and 3. So where there is 4 here is where we shall replace our 1 and 3. So meaning we shall have x squared plus x plus 3x plus 3 is equal to 0. And when you look at this, x plus 3x is the same as 4x. So now at this point, you just pair them up, pair this, and also pair this one. So the common factor here is going to be x into x plus 1 plus 3 into x plus 1 equaling to 0. So you end up with x plus 1, x plus 3 equals to 0. And once you solve, you get your x is equal to -1 and x is equal to -3. Anyone who got those answers, you were very, very correct. Yes, Mark. Yes, Mark. Oh, okay. Mark, I didn't get. Okay, Mark, I didn't get you well. Your network is not clear, but probably type in the chat. Then those who are familiar, in case those who want to use the bulldozer, please also you can use it, but always make sure that you do not make any mistake. And always, whenever you enter an exam for your finals, because you don't know, you know that kind of pressure we have towards exams, please ask for the logbook such that you are very sure of the bulldozer method. So it is -b plus minus b squared minus 4sc out of 2a. This out is out of everything. So now remember your quadratic equation is written in this form, bx plus c is equal to 0. So when it comes here, it means that your a, when it comes to this equation, will be 1, your b will be 4, and your c will be 3. So you substitute in this equation. But make sure you don't make a mistake to avoid losing out those marks. Okay, then the next thing I think I don't want everyone to fail is this number. At least if at all you think you may fail, or I don't want you to have that thing, but at times we may make a mistake. I want you as always to prove our answers. I want you to prove that the answer you have is correct. Please always prove your answer after working out. So I want us to prove. Now, in order for you to be able to prove that your answer is correct, we use our calculators. Anyone having a calculator, I want us to do it together. Those having calculators, but original calculators, FX100. FX100 can do it, MS or FX991. So follow the procedure. I want us to do it together such that you prove your answer is such that you don't write wrong answers. That even if you have made a mistake, you can easily notice. When you are using a calculator, you always first extract what is your A, what is your B, and what is your C. Now, for such an equation, our A, these are our different variables. So those having calculators, place mod. Let us go together. After placing mod, you will get something like comp and complex. You get comp and you get something like complex. Continue placing mod. You will get SD. you will get reg, and you will get base. Continue placing. You will get something like having EQN. EQN means an equation. So get there. Place number 1. Hope we are moving together. Let me not leave anyone. So after reaching equation, place number 1. After placing number 1, you are going to get something like unknown. So you'll get 2 and 3. Don't place it. Continue placing mod. Look at what we have, degree. So once you reach on degree, there is 2 and 3. So this one, our highest degree of a quadratic equation at this level is 2. So you are going to place number 2. So you are going to place number 2. So when you place number 2, you are going to get A, something like an A with that. So now there where there is A, you are going to place in our 1 here. And after, place equal sign. B is going to appear. Place our B is 4. Place 4. Place an equal sign. Then C is going to appear. Place C is 3. Place number 3 and place equal. So your answer, you are going to get x1 as -1 and x2 equals to -3. So that is how you use your calculator to obtain your right answers. Hope that is very okay. Okay. Someone has said we have left him. Okay, let us repeat once. Go to mod. Those having calculators, go to mod. The first thing you'll get, mod is after on mod. It is there near each other. Then the first thing you get is comp and complex. Continue pressing mod. You'll get SD, reg, and base. Continue pressing, you'll get equation. So place 1, number 1, equation 1, then press number 1. After pressing number 1, you are going to get unknown 2 and 3. Ignore that. Those are spontaneous equations. Continue pressing degree. So in a degree, we have 2 and 3. So place number 2. After pressing number 2, we have our A for this equation was 1, our B was 4, and our C was 3. So where the A, place 1 and C equals, go to B, place number 4, place equals, go to C, place 3, place equals. Then you'll be able to get your answers -1 and -3. Hope Mercy. Okay, very good. Yes, now we continue to the second number of functions. Let me hope everyone is there. Now the second number of function, we are going to do a section B number, and hope you are seeing it. For this number of section B, we use at least 10 minutes. So we are going to use 10 minutes to do it. Let us start. We are using 10 minutes to do a whole number of functions. But in case you have a question, leave it in the chat, but let us start on number 13. That is the one we are doing. Mark A squared plus B squared. No, that identity is not there. That identity is not there. Mark. Is asking how to go back in your calculator. Now to go back, place shift. Those who have not taken their calculator, sorry. Place shift. After pressing shift, place mod. So when you press shift mod, then you are going to get MCL, mod, and all. So place number 3, all, and then say reset all, then press an equal sign. Then it will be fine. I repeat, press shift, go to mode, go to number field, which says all. The first one is MCL, another one is mode, then all. Place number field, then place cosine. So mark the identity is a squared minus b squared. Okay. Okay, so we are doing number 13. When you finish, you place your answer in the chat. Thank you so much. Those who are sending in answers. Let us send in the answers. That is very good. This is very good. Thank you so much. I'm seeing very many answers. Okay. Should I take 27? Some people 27, 2, 3. Okay, I'm saying some people are finding it hard to solve the quadratic equation. Sorry, the simultaneous equation. Seems there are some people are still finding some challenges. Yes, sir. Yes, sir, Rodinez. Unmute. Yes, sir, Rodinez. Unmute.
Yes.
Yes, yes, sir.
Let me send my answer.
You have sent your answer. Okay, thank you so much.
Let me
Okay.
send, I haven't.
Oh, okay. Send your answer. Send your answer. Do we have anyone who wants to take us through how you have obtained your answer? Anyone who wants to take us through? Okay, okay. Abe, you want to take us through?
No, sir, I can't see.
You can't see my screen?
Yes.
Okay, I'm going to share it. Monica, do you want to take us through?
Yes, sir.
Okay.
For part A.
Part A. Okay,
I want to take it through for part A.
Okay, okay. Let me first reshare such that the other person can also be able to see the screen. So you are going to tell me what to write, or you want to write?
No. It's okay, sir, you can write.
Okay. Okay. Monica, we are ready. Let me.
So, in part A, they've given us, okay, I'm going to give you the full question, but I'm going to share with you the major factors. In part A, they've told us fx is equal to ax squared plus bx squared. Then they've given us if f into 1 is equal to 5 and f into 2 is equal to 14. They want the values of a and b. So in functions, we know that when the number in the brackets, always it's the value for x. So in this case, in the first equation, you are going to say you're going to say a times 1 squared plus b times 1 is equal to 5. Then you're going to say, for the second part, you're going to say a times 2 squared plus b times 2 is equal to 14. Then we are going to go back here and we say 1 squared is the same as 1. So you're going to say a, like to put things in short. You're going to say a because a times 1, of course, we have to get a plus b. B times 1, you're going to get b is equal to 5. Then you're going to say a times 4, which is 4a, plus 2 is equal to 14. 4a plus 2b is equal to 14. So we have these two equations, and as we see, we have two unknowns that are the same. So we are going to say, we're going to arrange them like vertically. But we see these equations like they have different numbers, like the numbers are not the same, like the number on the unknowns. So you have to make them the same. So up here, like in the first equation, you're going to multiply it by 4. In the first equation, you're going to multiply the whole of it by 4. And then down here, you're going to multiply by 1 to make at least the first unknown to be the same so as to get it easily. So you're going to get 4a plus 4b plus 4b is equal to 20. Then 4a, then this one, you're going to just recopy it because any number times 1, you still get all the same numbers.
I have a question.
And then we are going to subtract. Yes, a question.
Yes, I can see.
Yes. Can I continue?
Oh, like I'm still asking.
Okay.
Is it a mistake?
Yes.
I have to multiply by 4.
Yes. I'm not getting you, please.
So,
excuse me, I'm not getting you.
Ron, can we ask you to use the chat? Kindly use the chat.
I'm not getting you. Mr. Kaziwa, can we continue?
Yes, I'm not getting him also. Let me use the chat.
Mr. Kaziwa, can we continue?
Yes, Monica, we can continue.
Can I continue? Okay. So
yes.
We're going to eliminate this method that I'm using is called elimination method. So I'm going to eliminate this 4a, and the 4a, I'm going to remain with 0. Here, in the first part, 4a minus 4a, I'm going to remain with 0 plus 2b. This 4b minus 2b, I'm going to remain with 4b, is equal to 7. No, it's not 7, sorry. It's 6, sorry, I had made a mistake. 2b, we're going to divide both sides. You're going to recopy this equation, the remaining one, so as to get the value of b. We divide both sides by 2. Then we are going to get our answer as 3. And so we are going to use this answer that we've got. You're going to get any equation, any of these 2 equations. You're going to substitute in this value of a. Then you're going to say a plus 3 is equal to 5. Then you're going to substitute this 3 where b is, so as to get the value of a. Then you're going to say a plus 3 minus 3 is equal to 5 minus 3. And we're going to get our answer as 2.
Okay, thank you so much. Continue, Monica.
So you're going to get the value of A, which is 3, then these 2. Then on the second part, this is part 1. In part 1, they wanted the values of A and B. So here, as we've gotten them, on the second part, which is part 2, they want the value of F into 3. Then thank you, sir. This is it. So we are going to, where there is X, you're going to put these 3 that they've given us in the brackets, because there in the first part we said the number that's in the brackets is always the value of X. So you're going to, where there is X, wherever you see X, you're going to put this 3, and it's going to be 2 times 3 squared plus 3 times 3. Then we are going to first work upon this squared, like this squared number, which is 2 times 9 plus 9. And we are going to get, 18 plus 9, which is going to give us 27. Those were my answers. I don't know if they are right or wrong, but that's the approach I use. And someone who asked the method I use this method I used to find the value of A and B. That's called elimination method. I always use that method because to me it's the simplest.
Okay, thank you so much. Thank you so much, Monica. The answer is very fine.
So can I mute?
Yes.
Can I mute, or there is any question for me?
Okay, unless, is there someone having a question? In case you have a question for Monica. Oh. Monica?
Yes, sir.
Okay, I think it is very fine. It is very fine. Thank you so much, Monica. Thank you so much. That is how you had to do it. Okay. But here, when you are solving the simultaneous equation, always look out for the easiest method for you to use. Look out for the easiest method for you to use. Don't go in for the one that you don't understand. Look out, either you can use elimination, you can use matrix, you can use substitution. Any method can give you the right answer. Then part B, I saw answers were coming in. Do we have someone who wants to take us through part B? Okay, Emilia Joy, can you help me choose those people? I'm seeing some hands up. Okay. Yes, is it? Yes, sir. Yes, sir. Yes, sir. Oh, William.
Okay, let me take through this part of getting back the value of G into X.
Okay. Are you going to write or I write?
You can write.
I can write, eh?
Yeah.
Okay.
So they gave us the inverse of G into X as 5 minus 2x over 3.
Okay.
So on this question,
okay,
On this question, they want us to get into x, deriving it from the inverse. So our first step, we are going to let the value of g, the inverse of g into x be b. So after letting, we say b is equal to 5 minus negative 2x over 3. So the next step is to remove the denominator, which is 3. That is by multiplying it on either side. So on the side where there is 5 minus 2x over 3, it cancels and remain with 5 minus negative 2x being equaling to 3b. So therefore the next step, we remove 5, we take it to the side where there is 3b, where it becomes 3b minus 5 equals negative 2x. So after we aim at removing the coefficient of x by dividing it on either side. On this side, it becomes a positive, where remain x is equal to 3b minus 5 over negative 2. So after getting that, you have to replace back x in the place of b, and it becomes 3x minus 5 over negative 2 is equal to g into x. Yeah, that is how I got it.
Okay. Thank you so much. Thank you so much, William. William, can you give us, can you write it in a very beautiful way, better than this, without having a negative in the denominator?
Okay, it can be 3x plus 5 over 2.
Okay. Something is still missing, William. Remember, the negative affects both numbers.
Okay, negative 3x plus 5 over 2.
Negative 3x plus 5 out of 2. Okay, very good. We can beautify it and write it in, and so that is our answer. Thank you. So still, do you want to write it in a very best way? The best. Starting with positive.
Positive 5 plus minus 3x over 2.
Out of 2. Thank you so much. Thank you so much. This is the best way. All these two ways are very good, but the best way to conclude it is this one. In case you stop somewhere here, at times you may be denied a final mark. You may be denied a mark, much as it is very right. But always, let us avoid remaining with negatives in our denominators. So always ensure that you take it to the numerator. When it comes to the numerator, it affects both numbers. Thank you so much, William. I don't know whether I'm seeing some. Okay. Any question? In case you have any question for William? Yes, Lisa, you have a question? Okay. William, can you complete your question? William, unmute and complete your question.
Teacher, I had only prepared for this part.
Yes?
I had prepared for only this part, maybe some us with the next one.
Okay. Anyone who wants to take us through the next part? Anyone who wants to take us through the next part, raise up your hand and you take us through. No one? Okay. Okay. Now the next part was telling us that the value of P for which they gave us our G into 2x minus 3 is equal to f of x. So like they have been telling us that where in the position of x, we shall substitute 2x minus 3. So when you look at our G of x, we have gotten our answer as 5 minus 3x out of 2. Meaning that now in the position where we have x, we are going to substitute 2x minus 3. So we can first work it out. We say 5 minus 3 into 2x minus 3, but everything divided by 2. So what are we going to end up with? So now when we are opening, this negative 3 will affect this. The same negative 3 affects this. So we shall have 5 minus 3 times 2x. Then this negative and the negative will yield a positive. So we shall have 3 times 3, everything out of 2. So we end up with 5 minus 3 times 2x. We end up with minus 6x plus 9 out of 2. So when we collect like terms, it means that now I have the 5 and I have the 9. So this 5 here and this 9, I can add them together. So once I add them, it means I'll have 5 plus 9 minus 6x out of 2. And this one, you are noticing it will give us 14 minus 6x out of 2. So what I'm going to notice is that now, let me minimize this. Okay, now what we are remaining with is 14. This we are still on G2x minus 3. We are getting 14 minus 6x out of 2. So this 2 affects both numbers, meaning we can have 14 out of 2 minus 6x out of 2. So 14 divided by 2 is 7 minus 6 divided by 2 is 3x. So that is our G into 2x minus 3. But they told us that equate what you get here with f of x. So we are going to equate the 2. So I'm going to have 7 minus 3x is equal to f of x. So our f of x, I remember. Oh, can someone remind us what we had for f of x? What was our a? Was our a 2? Unmute.
Yes,
What?
A was 2 and then B was 3.
Okay, so we had 2x squared plus 3x. So what are we going to do? We are going to form a quadratic equation. We are going to collect like terms. So this minus 3x can come the other side. So we share 7 minus 3x plus 3x is equal to 2x squared plus 3x plus 3x. So we have 7 equals to 2x squared plus 3x plus 3x is 6x. We get this 7, we take it to the other side. So we shall say 7 minus 7 is equal to 2x squared plus 6x minus the 7. So meaning that now, can any co-host help me to pick out those people? And we hear what they are saying. So our equation will become 2x squared plus 6x minus 7 is equal to 0, which is a quadratic equation. Can everyone solve that and we see which answers we are getting? Can everyone, can we solve out those and we see, type your answer in the chat, and we see which answers are we coming up with for x, for the value of p. Oh, sorry, I am saying, wait, there is a mistake, sorry. Our f of x for part B was px plus 7. Sorry, it was not the first one. Let us first make that correction. I did not notice. Sorry. Let's first repeat that part where we are equating. So they told us our g of x was 2x minus 3, which was 7 minus 3x. And our f of x for part B was px plus 7. So these are the two we are going to equate, sorry. So meaning we shall have 7 minus 3x is equal to px plus 7. So that is what we are supposed to equate, okay? Let us equate this. So we are going to collect like terms. So we can have the 7 come this side. So we shall have 7 minus 7 minus 3x is equal to px plus 7 minus 7. So 7 minus 7 is 0. So we have minus 3x equaling to px. So now we are going to collect like terms. Hope everyone is getting. When you look at part B, I did not look at it. The equation was f of x was px plus 7. So we shall have minus 3x is equal to px. So when you collect the like terms, it means that you are going to have the x on one side. So I can have this one go this side or this one go that side. So I have minus 3x plus 3x is equal to px plus 3x. So here we shall remain with 0 is equal to px plus 3x. So when you look at this, our common factor is x. We can factor it out. So meaning I'll have x into p plus 3 equaling to 0. This one means that either we shall have our x is equal to 0 or our p plus 3 is equal to 0. So when you solve for p, it means we shall have p plus 3 minus 3 equals to 0 minus 3, and our p will equal to negative 3. So that is the answer. Anyone who had that answer, you are very... Oh, okay. Okay. Someone is telling me has not understood. Okay, ask the question and we hope from that part where you have not understood. When you look at part B, when we look at part B, we had two things. We had g of x and they gave us f of x. And they told us that equate those two things for Roman 2 to get the value of p. So that's why we have equated. So when you look at what we are equating, our g of x, we have got our result. Our result we got was 7 minus 3x. So you equate to p of x, which was px plus 7. Okay. I think, oh, now someone is asking, what if I divide by x? That one is also fine. It can also work, but it will not be good mathematics. Yes, more so when you find a quadratic equation. Someone is asking, what if I just say x, I just cancel out? That one is also very fine. It can work. Don't mind about it. Yes, but when you find a quadratic equation, please collect like terms. But always, I would recommend that we make you learn how to factor out. It is the best mathematics. Okay. Now I think we can go to the next question. Let me share my screen. Which should we look at? We have looked at functions. So now I will expect that we try out functions. Now we are going back to paper 1. We have been in paper 2. Can we choose the number we are to try out in paper 2? Okay, in paper 1, type in the chat quickly such that we know which number should we try out the topic. Okay. Transformation, I'm waiting. We are going to take on the majority, the number that will be chosen. One is saying transformation, vectors, matrices, translation vectors. Okay, trigonometry, transformation, vector. Okay, vector is overtaking. Vectors is overtaking, which is still paper 2. Let us go to paper 2 and revise a number of vectors. Then we shall go back, don't worry. So we are going to first look out for vectors. The first number is here, number 6. So we are going to do a number in section A and a number in section B. Can we first try out number 6? We said we are using 4 means to try it out. Let's do number 6, vectors. Okay, very good. Good. Okay. I'm seeing very many answers coming in. Thank you, Shatra. Mujuni. Oh. Okay. Joy, you are going to present. After this. Get ready. Thank you so much. Okay. Very good. It seems the number is a bit tricky. It seems the number is very tricky. I'm not seeing some correct answers coming in. And when I check, I'm seeing it is time. I'm saying it is already time, the 4 minutes we agreed on. Can we have someone who wants to take us through? Raise up your hand. Abby, you want to take us through? Yes.
No, sir. I can only send a message to the host.
Okay, you can now. Check, you can send now.
No, I'm saying I can only send a message to the host. How can I change to send to everyone?
Okay, I have disabled it. It is enabled now. You can send to everyone.
Okay.
Okay. Okay. Okay. It seems the number is a bit challenging. I've not seen any right answer coming in at the moment, but thank you so much for trying. The 4 minutes are done. We can now do it together. We can do it now together. I thank all those that have tried. Thank you so much for trying. Okay, now what do we have? Okay. Okay, so when you look at what we have, they have given us 2 things. One, they have told us that our P is given in form of a column vector, x into x plus 2. And then they have told us this is equal to 10. So when you look at what they have given us, this one means magnitude. Magnitude. When you have, let me say you have your, this, in case this is my vector, in case this is my vector P, magnitude means they have given us this. This is what they have given us. So this is our x and this is our y. So whenever you find yourself having magnitude, magnitude means get the x component squared plus the y component squared. Take an example. In case our P was 2, 3, this one means that to get magnitude of P, you will come and say square root of x squared is 2 squared plus 3 squared. Always when you find a column vector, always the first component is x, the second component is y. So it is 1 you square. It's Pythagoras theorem, meaning here we have 4 plus 9, which will give us, this is 4 plus 9. I think this is 13, and you get the answer. So that is how you do it. So still here, the same thing they have given us when it comes to our P. The only unique thing now they have done that they have given us unknowns. And when you have unknowns, it means that you do it differently. So how are we going to do it? They have given us our P as x and x plus 2. So meaning that now, what are we going to do? We are going to have this one squared. We shall square the x, we shall square the y. So our magnitude of P will equal to square root of x squared plus x plus 2 also squared. So what are we going to have? Magnitude of P is 10 equaling to the square root of x squared plus x plus 2, all of it squared. So we can remove this square root by squaring on both sides. I can square this side, I square this side. So when I square 10, I'll have 100. This side, this and this will cancel. I remain with x squared plus x plus 2, all of it squared. Now my task is expanding this. So that is why I think some of us are going wrong. So when you are expanding, let us apply the expansion. Well, so you have x plus 2 squared. This is the same as x plus 2 into x plus 2. So you open up the brackets, you know very well that this x multiplies everything here. So you say x into x plus 2 plus still this 2 multiplies everything. So you say 2 into x plus 2. So once you open up the bracket, the x affects here, the x affects. So you get x squared plus 2x plus 2x plus 4. And you end up with x squared plus 4x plus 4. That is what we shall substitute here. So we shall have 100 equaling to x squared plus x squared plus 4x plus 4. So when we continue, you are noticing this will be 100 equals x squared plus x squared. We end up with 2x squared plus 4x plus 4. Okay, can we first take on those hands? Abiola.
Excuse me, sir, I've got lost on any port stems. when you put 10 squared in that step.
Which step?
Where there is 10 squared equals the square root of x squared plus x plus 2. That step.
Okay, okay, Abiola, don't mute. Now, Abiola, when I have 4 equals to root of x, how do we remove this square root?
By squaring the 4.
So I square this side, I square this side. So 4 squared will give me 16. And this side, what shall remain with?
X.
So that's how. Is it fine now?
Yeah, it's fine.
Okay. Now, this is a quadratic equation, so we shall collect like terms. So we take the 100 the other side. So we shall say 100 minus 100 is equal to 2x squared plus 4x plus 4 minus 100. So we end up with 2x squared plus 4x. Then when you say 4 minus 100, that is 96, negative. So you have a negative 96 is equal to 0. So now your quadratic equation you are solving is 2x squared plus 4x minus 96 is equal to 0. And now, hope now we can be able to solve that. So solve and you tell me what you are getting. Type in the chat. I showed you how you can use your calculator. Never to fail. Very good. Hope, thank you. Very good. Very good. Very good. I'm seeing the right answers. X is equal to 6 and X is equal to negative 8. Those are the two answers you are supposed to get. Okay, very good. Thank you, everyone. Ojilong, very good. Very good. Those getting negative 8. But remember, we need always to read the question very well, such that we do not make a mistake. Remember, the question is telling us values, so meaning that they are expecting us to get 2 values. So that's why X is equal to 6 and X is equal to negative 8. Thank you so much, everyone. Emilia Joy. Joy. Okay, let me check out. Okay. Okay, Emilia Joy, take us through vectors. Arthur, I don't know whether you are ready to take us through your second presentation after Joy. Send me a message, Arthur. Okay, Joy, you are welcome. You can take us through.
Thank you, Mr. Kaziba. So I'll be going through number 14, which is the vector number, and it's a section B number. So this question said that in a triangle AOB, AO is equal to A, OB is equal to B, C is a point on AB such that SC to AB is equal to 1 to 3, and D is the midpoint of OB. So we can see our figure, which was given to us, where we'll see the different vectors, the triangle they talked about, OAB. So our first question said that express the following vectors in terms of AB. Our first vector they gave us to express in terms of AB was of A and B is vector AB. So we can see the direction vector AB takes. Vector AB moves from A to B. And therefore, in vectors, we are meant to find an alternative route. For that way, there is a direct route from A to B, and there is also the route from A to O and O to B. Therefore, we'll say that AB is equal to AO plus OB. We know that AO is the reverse of OA. That is because in OA, you're moving from O to A. Now, when you're returning, you're changing your direction, and therefore you're moving backwards. In short, you're going back where you came from, and when you move back, normally it's a negative move. Therefore, in this case, we'll have that AB is equal to OA plus OB. AB will be equal to A plus B. And since we do not, it's better to state answers starting with a positive, we'll say that AB is equal to B minus A. We'll then move to the next one where they told us to express OC in terms of A and B. So OC moves from O to C. In this case, the alternative route we shall be using is O to A to C. There is an option of O to B and C and B to C, but that requires us to find BC. On the other hand, if we use the one I'm going to use, O to A and A to C, it's easier because somewhere in the question they talked about AC. So we know we can easily find what AC is, unlike finding CB, which will have to give us a negative of its reverse direction, which will be BC. So OC will be equal to OA plus AC. And we say that AC to AB is 1 to 3. Therefore, SC is a third of AB. Then continue to say that AC is equal to a third in two brackets, B minus A. That is because in the previous number in the part we have just done, we found our AB as B minus A. Occurred. Occurred.
Yes. Yes, please.
You raised your hand. What could be the matter?
Hello?
You raised your hand. What could be the matter?
I wanted to pass through that again.
Pass through what?
I haven't picked it.
To pass through what?
Yeah, at least just start, just begin afresh, huh? So that I pick it so clear.
Sure. Okay, so our first part of this question said that we find AB. AB moves from A to B. I said vectors is basically an alternative route. So in this case, the alternative route from A to B is from A to O and O to B. Therefore, we shall say that AB is equal to AO plus OB. I then say that AO is the negative of OA, and we'll state that too. Then we'll have that AB is equal to negative A plus B. AB is equal to B minus A because it's the same expression. It's just that when you start with a positive, the expression looks better. I then continued to say we are finding OC. That was the next part of this question. OC is basically what I've outlined there. And I said there are two routes from O to C. There are three routes. There is the direct route, and then there is the route from O to B and from B to C. There is also the route from O to A and from A to C. In this case, I'll be using the route from O to A and A to C because this is more direct, since in the question they talked about AC. So finding AC will not be hard as finding CB. Therefore, after saying OC is equal to OA plus AC, I'll find AC, which they said AC to AB is 1 to 3. So AC will be a third AB. And there I will say that AC is equal to a third into brackets B minus A. That's because from the previous number, we found that AB is B minus A. I'll then continue to say that OC is equal to A. In this case, I'm now filling in from the above, from the first statement I stated that OC is OA plus AB. Now I'm substituting. So I'll have OC is equal to A plus a third into brackets B minus A. At this point, I'll use the LCM and have all of them to have a common denominator. So we'll have OC is equal to 3A plus B minus A. From that step, I'll have OC is equal to B plus 3A minus A. That's in this stage I've collected the like terms. That's to say the A's together. And then I'll have OC is equal to B plus 2A divided by 3. I'll factorize out the third, and therefore I'll have OC is equal to add into brackets B plus 2A. I'll then continue to the next part, which say that I express AD in terms of A and B. So AD is that root as we can see it. And just like OC, AD also has two roots, which can get to it. There is a root from A to O and O to D. There is also the root from A to B and B to D. In this case, I'll use the root from A to O and O. In this case, I'll use the root from A to O and O to D. So AO, so we'll say that AD is equal to AO plus OD. We know from our previous number that AO is negative OA. And from the question said that D is the midpoint of OB. Therefore, D, for something to be in the middle, that means it bisects the thing into a half. Therefore, OD is a half OB. So we'll have that there too, and we'll go back to finding our AD, where we'll have AD is equal to negative OA, since AO is negative OA, plus a half OB, since OD is equal to a half OB. We'll then continue to say that AD is negative A plus a half B. We'll calculate further and say that AD is equal to negative A plus B divided by 2. We'll then use the LCM method and have everything out of 2. So I'll have negative 2A plus B minus 2. Putting the negative inside, we'll have B minus 2A out of 2, and we'll factorize out our half to have B minus 2A. We'll then continue to the next part, which said that X is a point on AD such that AX to AD is 4 to 5. From there, it said, find in terms of A and B, the vectors AX. That's the first vector I want us to find. So we'll go ahead to state. We'll go ahead to state that AX to AD is equal to 4 to 5. We are going to use this ratio to find AX. AX is therefore equal to 4 out of 5 AD. In our previous example, we saw that AD is equal to a half into brackets B minus 2A. Therefore, AX will be equal to 4 out of 5 times a half into brackets B minus 2A. When the 4 and 2, when we are carrying out the multiplication here, these 2 will become 1, while this will become 2. This therefore gives us our answer to be AX is equal to 2 out of 5 B minus 2A. I'll then continue to the next part, which was finding OX. I think we can all see what OX is. Now, there are a number of routes to OX. That is to say, from O to D, from D to X, there is O to B to C to X, there is O to A, from A to X. I'm going to use the route from O to A to X, because I have AX and I also have OA. Therefore, I'll say that OX is equal to OA plus AX. I'll then say that my AX is equal to 2 out of 5 B minus 2A. Therefore, OX is equal to A plus 2 out of 5 B minus 2A. We'll have OX is equal to 5A plus 2 plus 2B minus 4A. When we collect like terms, the 5 minus the 4 gives us an A. Therefore, our OX will be 2B plus A out of 5. OX will be out of 5 into part of this in the simple ratio OX to OC. Abby, you have a question?
Can you please put back the previous screen? I have a question.
Yes, please.
That what is it? The third last point.
OX is equal to 5A plus 2B.
That point.
Pardon?
Like how you get that point. 5A plus 2 minus 4 out of 5.
Okay, so when you use LCM, when you get out of and all that, you will have 5A. You get, this will become times 5 since its denominator is 1. Yes, here I will multiply by 1 since the denominator is 5. So in this case, we'll have 5A because 5 times A is 5A plus, now this one here times the 2 it found there is giving us 2. So we are going to multiply that 2 to open our brackets, the numbers in brackets. So instead of us, we would simply have 2 into brackets, B minus 2A. But now in this case, we are going to have to open this bracket further. So that we have plus 2B minus 4A. So that's how I'm able to get to the point where I say 5A plus 2B minus 4A. Is that okay, Abby? Abby? Okay. Maria?
Joy, she has replied she's okay.
Okay, thank you.
I beg your
Maria?
pardon on the value of AX.
Pardon?
I beg your pardon on AX.
Value of?
AX.
AX. Okay, so how to... So I said that AX, since our question says that AX to AD AX is equal to 45. So AX to AD will have that AX, our A and X, will be equal to 4 out of 5. And we'll also have the AD this side. AX is equal to 4 out of 5 AD. From our previous example, from the number before this, we found out that AD is equal to a half B minus 2A. AX is therefore equal to 4 out of 5 times a half into brackets 2 minus 2A. This is the AD. So we are now multiplying with the AD, expanding it. Since here it was AD, we're now replacing it. So I said the 4 cancels out. The 4 and the 2 reduce each other. So the 2 becomes 1, while the 4 is going to become 2. And from that step, we therefore have that AX is equal to 2 out of 5 B minus 2A. Is that okay, Maria? Maria? Okay, so I think we can move on to the last part of this number. So the last part said, find in the simplest form the ratio OX to OC. Now we found out that our OX is equal to 1 out of 5 to B plus A. And we also found out that OC is equal to a third B plus 2A. Therefore, OX out of OC is going to be equal to 1 out of 5 2B plus A, right? Out of 3B plus 2. This simply indicates that despite the number showing us that OX and OC are a straight line, they are not. In a normal circumstance, the vector OX, the vector 2B plus A or B plus 2A is supposed to look alike. And in that case, we cancel them out and find the ratio that is being used to express OX and OC. But in today's case, I don't think that's possible. So this was my simplest form for that number. Any questions?
Emily, do you mind taking us back to part B?
Which part of part B? There was the part that had AX and the part that had OX. Which one would you like?
Like the immediate part before this one.
Sure. Rosaline? Kwaga? Kwaga. Rosaline? Rosaline? Abby?
You first help me here. Like now, what? Let me say this point. The last question.
Yes, please.
Yeah, that one. Now, what if they tell us, show that OX to OC will equal to 3 to 1? How do you do it?
You work out you work it out the same way I had started it. And you're basically not supposed to use the ratio they have given in the question. You're supposed to get there by working it out by starting off like this. Is that okay? Abby?
No, I beg your pardon.
I said that when they say show that OX to OC is, let me say, 1 to 1, you're going to basically find the simplest ratio of OX to OC. It's just that this time when you're finding the simplest ratio, you should get the answer 1 to 1. So if you do not get that answer, that simply implies that what you have done has an error somewhere.
Okay, thank you.
Yes, Flavia.
So yes, Joy, are you able to hear me?
Yes, I can hear you.
So I'm asking, when it's the same case, when they tell you, show whether these two are collinear, do you use the same approach or it is something else?
When you're to show that two things are collinear, that means you can express the lines as in a ratio, for example. For example, the way they expressed SC and AB, telling us that SC to AB is 1 to 3. That means that those two lines are collinear. The only way I can express two lines that means that the lines are parallel. But to show that they are collinear, so normally the issue comes in conclusion. So here you're going to work it out the normal way, basically the same way as this. And then you conclude saying that since, let me say, for example, SC can be expressed in terms of AB, because by the time you're saying that SC is a third, let me say AB, you're expressing it in terms of the other. So since SC can be expressed in terms of AB, the two lines are parallel. And because they share a common point A, they are collinear. Is that okay? Let's see.
Yeah, it is okay. She has replied in the chat.
Monica?
Excuse me, can you use any example how coordinality? Because that
Monica, do you mind typing your issue in the chat? I can't hear you at all. You keep breaking. Spacey?
What if you're asked to show that QAB equal to RBC? How can you do that?
May you repeat what you've said? Spacey? Okay, Spacey, you can now unmute. Okay.
How can you do that?
Okay, so Monica's question was, can you use any example to show how to prove the collinearity of points? Okay, so in this case, I'm going to choose onto, let me choose onto AC and AB. Okay, so at this point, we have that AB is equal to AO plus. Okay, so from here, we have that AC is equal to AB, 1 in the ratio of 1 to 3. I want us to use this on the previous number, the previous part. From here, if we are showing that 2 points are collinear, you have to pick, let me say that show that points A, C, B are collinear. You make 2 vectors. Normally, I make the vector AB and AC. I find it easier that way for me. So with the vector AB, that one I know it now. Now, for example, if I'm to find AC in this case, I'm going to say from what we've been given, AC is a third, AB. So AC is a third, B minus A. So in this case where we have decided that we are using, what do I say? That we are using AC and AB, we are done finding our AB, which is B minus A, and we have also calculated and found our AC, which is a third B minus A. To show that these 2 points are collinear, I'm going to simply just conclude, because that's where now the other mark comes in. The first part is for you to identify the points which they want and make 2 vectors out of it. I made 2 vectors, that is to say A to B, AB and AC. Find each of those vectors. We found AB, which is B minus A. We also found AC, which is a third, B minus A. Therefore, we'll say that the points that the vectors C and AB are parallel. This is because they share a common vector, B minus A. From there, I'll then say, therefore, the points A, C, and B lie on a straight line because the vectors share a common point A. Monica, is that okay?
Yeah, it's okay. I've got you. Thank you very much.
You're welcome. Mr. Kaziba, I hand over to you.
Okay, thank you so much. Thank you so much, Joy, for taking us through vectors. And let me hope everyone has understood how to deal with those numbers concerning vectors. In case you have not done vectors at school, please do not risk to attempt it in section B because it will cost you heavily. Always attempt the ones of section A. So section A numbers of vectors, you might section A numbers are doable for vectors because that is senior 1, senior 2 work of vectors. But I kindly request you, do not go in for a vector number if at all you are not sure on what to do. But for section A numbers are compulsory. You must do it. For vectors, you are going always to find the 2 numbers when it comes to paper 2. You'll find a number in section A. You're also going to find a number in section B. For every vector, for every paper 2, there are always 2 numbers of vectors, one in section A, another one in section B. So meaning that if at all you know them very well, it means that you have already obtained good marks when it comes to paper 2. The same thing happens when it comes to functions and mapping. You always find 2 numbers, one in section A, one in section B. But for vectors, go for it when you are ready for it. If at all you are not ready, please ignore it in section B. So this is one of them. You find that in section A, the number is there. Even when you look at functions, there is always a number in section A. Come in section B, you'll find a number of functions. So meaning if at all you have already mastered functions very well, you have 2 numbers. You have the 4 marks in section A, you have the 12 marks here, which will give you 16 marks already. Come, look at vectors. Vectors in section A, we have a number already. It will be there in section B. But go for it when you are strong in math. If at all you are not so strong in math, don't do the one in section B, but try the one of section A. The same thing is going to happen when it comes to set theory. Always there is a number in section A and there is a number in section B. You'll find that there is a set here, and also you'll find that you'll find a second number of set theory when it comes to section B. So meaning that there are some topics you must be knowing. That is set theory. You must be knowing the number of vectors. You must be knowing the number of functions. Those are compulsory numbers that will be appearing. Section A, section B. Then there you can add on man or business. When it comes also to business math, there is a number always in section A and there is a number in section B. You'll find that there is business math here, and also in section B, you'll find that there is a number concerning the business. Meaning that anyone who has understood business, you have 4 marks section A, you have these marks. When it comes to vectors, you have 4, you have 4. When it comes to functions, you have 4, you have the 12. When it comes to number of functions, vectors, business, there's a number I'm forgetting. Which number in section B. But already those are very good marks for you. Those are very good marks for you, and you're already having a credit. Just mere passing those 3 numbers, 412, 412, 412, you'll be already having a credit. But remember, we are looking for a distinction. Okay, let me invite Arthur. Are you ready? Arthur?
Yes, I'm ready.
Okay. After you can take us to the second number.
Okay. Thank you. Let me get again this other gadget. Uh, mm, okay, I was requesting if you could put my other gadget on co-host so that I can share the next number. Thank you. So, um, okay, 13, I'm doing number 13, which say it's also about matrix. So, it talks about, it says, first it says, given that matrix A is equals to 2, 1, 1, 3, evaluate b squared minus 2b. So, what b squared means is b squared is b times b minus 2 times b. So we first find out what b squared is. And then we also find out what 2 times b is. Now b squared is 2113 times 2113. And then the 2 times b is 2, then open quotes, 2113. So now we multiply b times b, and b times b, we shall get this 2 times this 2, we get 4 plus this 1 times this 1, we get 1, and when we add that we get 5 here. When we add that we get 5 here. Then here we say for this bottom one here, what we do, we say 2 times sorry, we say 1 times 3, so 1 times 2 we get 2, and 1 times 3 we get 3. When you add that you get 5. Then 1 times 1 for this one here, we get 2 plus 2 times 1 times 3, we get 3. When we add that we get 5. And then here we shall get 2 at the bottom here we shall get 1 times 3. 1 times 1 is 1 plus, just give me a second. So 2 times 2. Okay, then first say something. Yeah. So here we have 1 times this one multiplies with this 1 here, and this multiplies with this us to get this. So here when you say 1 times 1 you get 1, plus 3 times 3 we get 9. When you add that we get 10. This is a square. This is b squared. This is b squared, and now we say minus that 2 times b, and 2 times b is 2 times this matrix of b, which is 2113. So it's 2 multiplies with this multiplies with this, multiplies with this, and this. So 2 times 2 is 4, 1 times 2 is 2, 1 times 2 is 2, and 2 times 3 is 6. So we subtract that, well, this subtracts with this subtracts with this subtracts with this, and this subtracts with this. So we in the end get 1, 3, 3, 4. So part B, that's what we got. That's what we get. And for part A, that's what we get. Then for part D, we have the question says in a supermarket, 8,000 can buy three apples and 2 mangoes. 19,000 can buy 4 apples and 5 mangoes. Represent this information in matrix form. And then the second Roman says find the price of an apple and a mango. So first write the information in matrix form. And the information in matrix form is here. And it makes sense because they say 3 apples and 2 mangoes can buy 8,000. And how we can prove that is 3, this 3 times this apple and this 2 times this mangoes. So I say 3 apples plus 2 mangoes is equal to 8,000. 8,000 and the zeros continue. 1,000. So that's that. Now that's one equation. Then the second equation is 4 apples and 5 mangoes. 13,000 is used to buy 4 apples and 5 mangoes. I get 13,000. So that's the information presented in matrix form. Now we go to part Roman 2. Find the price of an apple and a mango. Now how we do that? We have to solve this equation that we have made here, and it is actually like a quadratic equation. So let me continue. So this quadratic equation is what I had said. There are three apples plus 2 mangoes equals 8,000, and also 4 apples plus 5 mangoes equals 13,000. First we find the adjoint, as we all know it, and major diagonals change the 5 and 3, and in the minor diagonals the signs change. So we multiply, we put the adjoint here, and as Kaziva said that the positions matter. So this one goes before and this one goes after here. So when you multiply, this adjoint multiplies with this, and this multiplies with this. So this is 15 minus 8, so we get 7. And then to get this 0, we say 4 times negative 4 times 3 is negative 12, and 3 times 4 is 12, so we get 0. And then to get the position here, to get the position there, you say 5 times 2 minus 2 times 5, I get 0 because 10 minus negative 10, 10 plus negative 10 is 0. And then for this 7 here, I said 4 times 2, which is negative 4 times 2, it is negative 8. And 3 times 5 is 15, where I get 7. So now we continue upwards, and we can come apples and mangoes, and we come to this side. When we come to this side, this multiplies with this, and the reason why we have okay, it's a 2 by 1. The reason why we have this 2 by 1, we have, so when you multiply 2, like for example, if this is a 2 by 2 matrix and you're multiplying it with 2 by 1, if these two are the same, then then it can be multiplied, and then this is the order. It's repeated 2 by 1. So if I had put this adjoint this outside where you say 2 times 2 by 1 times by 2 by 2, these two are not the same. So it's not it can't be multiplied. So every time you have to first confirm whether they are same to see if they can be multiplied, and make sure that the adjoint is before the before that 2 by 1. So now so how we get this? We say 5 times 8, which is 14, minus 2 times 13, which is 20, negative 20, plus 2 times, plus 2 times negative 2 times 13, which is negative 26, where we get 14,000, and 4 times negative 4 times 8 is negative 32, plus 3 times 13, which is 39, we get 7,000. Now we use this the way we do it is this 7 multiplies with this, so we get 7 and 7 apples plus 0 mangoes, and that's equal to 14,000. 14,000, and that as we see it here, and then you divide both sides by 7 and get 2,000. And then for mangoes you do the same. This 0 multiplies with 0 apples. With apples you get 0 apples. This 7 multiplies with mangoes. You get 7 mangoes. Divide both sides by 7,000 and you will get 1,000. That's my number 13, my second number. Any questions? Okay. Evelyn, let's see.
I didn't get that part there of finding the price.
Okay. So I did the whole beginning. Okay, like let me show you. So like we have two equations, like solving a quadratic equation. And apples and mangoes are the unknowns. So what do we do? Okay, let me write down for you the equations so that we probably can show it like that. So we have three apples. Let's take apples as three, and then 2 mangoes, which is equal to 8,000, and then 4 apples and 5 mangoes. Now, when we find M, we have found the cost of 1 mango. When we find A, we have found 1 apple. Now, we try to we aim to find the cost of 1 apple and the cost of 1 mango. So, as we did in our first number, which was I think number 11, you yeah, it was number 11. Then which I showed you about solving simultaneous equation using matrix. So now, after you've put this equation, you just format it into a matrix, and then but you already have the matrix in part I, but you format it into a matrix, then you get the adjoint, and you multiply the adjoint on both sides of the equation, and then you know how I think you know how to multiply matrices. Matrix matrices, sorry. So you multiply them and you get 7007 apples and 14,000, 7,000 on the other side. So now, from this step, you go to this step here, where you have 7. Let's for now put apples in short form of A. So currently in our minds, this is A and this is M. So now we say 7A plus 0 in two brackets, and also here 0 plus 7M equals to 14,000, and then also here 7,000. Now what you do, you get this upper part of the equation and find A, and as we were taught in primary, 7A plus 0 will be equal to 7A, and well, we will equate it to 1,000. We equate it to 14,000, and A will be equal to 2,000. And then for M, 7M equals to, you also take the down part to get M. The upper part for A, down part for M equals to 7,000. Divide both sides by 7, and M is equals to 1,000. So M is mangoes, up, and A is apples. So once you found M and A, you have found the price of one apple and one mango. So you say therefore, one mango costs 1,000 shillings and one apple costs 2,000 shillings. Yeah, so any more questions?
Okay. Thank you so much, Arthur. I am sure people have really understood how to deal with the matrix. Thank you so much for leading us through that discussion. In case of any question concerning the matrix, please, we are going to be opening up the chat on our WhatsApp group, and then we shall ask you to ask your questions. But in case you have any burning question concerning mathematics, we can use this time to ask it. Or, but also I'm planning that next week we shall have another seminar for math to complete most of these things. So next week, get ready. I will have you'll have the timetable in your group. We are likely also to have other seminars for other subjects come next week. I will be letting you know of the program that we shall be following. But next week, we are likely to have, at least we shall have, I'm sure we shall have a chemistry seminar. I'm also talking to, we may also have English. We want to, we shall also have English next week. We are also likely, we shall also have physics next week. So next week we shall be a bit busy with the questions. So we shall have them next week. Very many seminars. So let us get ready and get the data that we need come next week. Someone is asking, I've seen a question. Someone was asking something in paper in the chat. Someone Oh, some are going back on Sunday. Sorry, those who are still around. Someone tap us the WhatsApp group number. When is that? Question 2 first paper. Okay, let me only work out that question. The one is saying question 2 first paper. I think this is the question. For this question, the only thing you do that you factorize out what you have. So when you look here in the numerator, you have x into x minus 3. And when you factorize out what you have down, if at all I'm not mistaken, you get x plus 7 and x minus 3. That is what you have to do. So this x minus 3 and this one, we are going to cancelling, so you remain with x out of x plus 7. So that's what to do. What studying is you factorizing out the denominator. So that's how we could do it. Otherwise, I think we have done a lot. I want to okay. Someone was asking, when plotting a cumulative curve, do we plot in the middle of the scale on horizontal axis, or we plot the whole class? Okay, let me check whether we have any. We don't plot in the middle, but I don't know whether we have any question here on cumulative frequency. I think we have one. Now, always those like when you are plotting the cumulative frequency, you don't plot in the middle, but always they must correspond to the upper class. Like remember now, like when you look at this question, you'll notice that our class boundary was 47 to 50.5, 50.5 to 53.5, 53.5 to 56.5. So always you plot your point at this point, at the upper class boundary, 50.5, 53.5, 56.5. So that is where you must have your point plotted. You don't plot in the middle, but plot on the upper class boundary. Plot the upper class boundaries. Okay, hope that is very fine. Those asking for the WhatsApp now group, let me get that link, and I see, give me a minute, I pick that link. Link for senior 4, or anyone who was it, you can pick it. You can pick it and share it. Link for senior 4. Okay. Then what of a histogram? Now for histogram, remember for it you plot the frequency against class boundary. So for it you do not you do not plot in the middle, but you encroach the class boundaries. In case this is your curve. So remember for you plot frequency against class boundary. So we shall be expecting you that 47.5 to 50.5, you encroach it very well, like that. In case there's another class, encroach it, and you must not have any space. So that's what you do. For it, it will be covering the whole class boundary when it comes to histogram. But I think we shall be emphasizing more come next week. We are going to get a day next week and see that we complete most of these questions. So for parts that we have not discussed, let us prepare ourselves next week such that we can discuss those parts. Otherwise, I want to thank you so much for your time. Thank you so much for joining. Thank you so much for sacrificing and buying the data. Thank you so much. We are really very happy, and we want to pray for you that you perform to the best. The link, I think the link, let me share it, sorry. Let me share the WhatsApp link. Thank you so much. I want to thank Arthur. I want to thank Emilia Joy and all those that have presented. Please, thank you so much for your time, for making those presentations. Monica, Thank you so much. We are really very happy, and we are just praying that the Almighty God blesses you and you work and things come out very, very well. Next week, we shall emphasize trigonometry. We shall look at those circle properties. I want also to thank Teacher Samuel for joining in the call. Teacher Samuel, I don't know whether you can unmute, and then you give a word to our candidates. Teacher Oneka Samuel, can you unmute and say something? Yes, Vanessa, you have a question? Okay, I'm failing to get Teacher Samuel, but thank you so much, Teacher Samuel, for joining the call, and thank you everyone. We shall meet next week for another seminar. I've said we want to have all subjects covered such that you go back when you're ready. We have shared some more papers for you to try out on the WhatsApp group. Please keep on trying and finish all the questions. Then in such that in case of any question, the teachers may be of hope. Thank you so much once again. Let me wish you a good afternoon. Those who are going for prayers, please wish you all the best. May I have someone to lead us in a closing prayer? Yes, Mas.
Let's humble ourselves and we pray. Heavenly Father, I would like to thank you so much for today. Thank you for this beautiful day that you have allowed us to have a seminar. Thank you for everything that has gone through this seminar. Thank you for everyone who has discussed. Thank you for whatever we have learned. We pray that you may help us to understand it more and to keep it in our minds, Father. Thank you for our teacher. Thank you for giving him that strength, that zeal, and that love for teaching us, Father. And Lord, we pray that as we are going in our different homes, different places, we pray that you be with us, bless us, and help us to understand more and more, even better, Father. Pray this all believing and trusting in you. Amen.
Okay, bye everyone. You can unmute and say bye-bye. Let us meet next weekend. Sorry, next week.
Bye.
Bye. Bye.
Bye.
Bye.
Bye bye.